Next, we'll discuss some software terminology. First, let's define software. Software is computer programs or instructions to perform a specific task. Software also determines what hardware is present, decides how hardware is configured and utilized, and works with hardware to perform tasks. Now, there are three different types of software. There's firmware, of which BIOS is an example, and typically this is hard-coded software and not easily changed. There's operating system software, which provides instructions to hardware to perform tasks, and there's application software, which actually performs a specific task. Software functions in a hierarchy. The hierarchy determines how the software interfaces, so that a high-level software can depend on a low-level software to manage the hardware for it. For example, application software depends on the operating system software to interface with hardware. The operating system software instructs the hardware directly, uses BIOS to provide the instructions, and uses device drivers, which are included with every piece of hardware. Software also uses memory addresses so that we can have many different types of applications running at the same time. As a matter of fact, we can use application software, operating system software, and BIOS and device driver software all at the same time because each has its own memory address. Let's focus on operating system software closer. Operating system software is written to support specific hardware in software, and it contains interfaces. There are many different types of interfaces. A command-driven interface is usually indicated with a C prompt. DOS was a program that started with a command-driven interface, and we still use command-driven interfaces to do some configuration, especially with TCP/IP configuration in networks. There are also menu-driven interfaces that we take for granted today in programs like Windows 95, Windows 98, and Windows 2000. And icon-driven interfaces are also another type of graphical user interface that operating systems use. Let's talk about some processing terms in regards to software. Multitasking can be accomplished in two different ways. With the earlier software and hardware, we used what was called cooperative multitasking or task switching. In this type of multitasking, the application actually controlled the processor. This created problems with earlier applications because they could actually hog the processor, making themselves look better and other programs not look as good. Now we use preemptive multitasking, where the operating system itself controls the processor. Common operating systems that we use are DOS, one of the first operating systems, called Disk Operating System. DOS with Windows 3.1 and 3.1.1 operating environments. Windows 3.1 was the original Windows and was, for some people, the first time that they used a multitasking operating system which allowed them to do more than one thing. Also was the first time that a lot of people used a mouse. Windows 95 and Windows 98 are the newer operating systems that have more features than Windows 3.1 and 3.1.1. We'll be discussing all of these operating systems in greater detail in later lessons. Unix operating system was first on mainframe computers and now is used on mainframe computers as well as some microcomputers. Windows NT was designed for business. NT stands for New Technology. And Windows NT came out around 1995 and was designed to provide businesses with a more stable and more secure operating system. Windows 2000 is an even more stable and more secure operating system that was just released in 2000. OS 2 is an operating system that was released by IBM and is used by some businesses but doesn't have the following of some of the Microsoft systems and Macintosh operating systems. Operating system modes include real mode, which is used by DOS. In real mode, we're talking about a single task operating mode. If we're doing one thing, that's all we can do. We'd have to close that to do something else. It only addressed 1024K of memory addresses, that's 1 meg of RAM. It had direct access to RAM, and it used a 16-bit data path. A 16-bit data path is like a 16-lane highway of ones and zeros. That's what we used in real mode. Real mode is typically not used today. Today we use protected mode. Protected mode supports multitasking because the operating system manages memory. Programs can have much more than 1 meg of memory addresses, and they typically use a 32-bit data path, which is like a 32-lane highway, and you can see what the advantage of that would be. So those are some common software terms. Let's summarize what we've learned. Individual components that make up a computer system are hardware and software. Hardware includes devices used for input, output, processing, and storage of data. Components that make up the electrical system are the power supply and the buses. Components used for communicating data are ports and RAM. The CPU is one of the most important components in the computer. It's the central processing point for all data and instructions, and it works along with memory to facilitate processing. Software works in layers. The lowest layer, BIOS and device drivers, interfaces with hardware. The highest layer are the applications themselves. The operating system software sits in the middle and coordinates everything. We have multitasking, meaning that we can work with more than one thing at a time. Older computers use real mode, while newer computers and operating systems use what's called protected mode. So now, let's take a look at the next lesson and see how hardware and software work together.